Yeah, so I'm doing my presentation on mathematics as an area of knowledge. So what I looked at starting when I looked at math was how versatile it was as an area of knowledge, and how it not only does it apply to its own area, but it ties into almost every other area of knowledge. So you can obviously can be used to create models in natural and human sciences, and then something unique about math is that it possesses beauty and elegance, where you could almost consider it a form of art because there's all kinds of different forms of it. But it's broadly universal, not tied to a particular culture. In other words, it's used all over the world, and and it's independent and complex. So it doesn't rely on any sense of perception of the real world, since it's a system itself. And then mathematicians require intuition and imagination in order to prove theorems. So yeah. So before you go into my real life situation, just to keep in mind, so as populations rise and technology increases in terms of pervasiveness, so do algorithms, and they become more and more used within society. And then so the area of knowledges and ways of knowing are mathematics, human sciences, and natural sciences. So here are the knowledge questions before getting into it. So, to what extent do algorithms control our lives? Why are algorithms increasing in importance? And can and should we reduce everything in the world into an algorithm? So this is my main knowledge question. So on August 4th, 2005, the police department of Memphis, Tennessee made so many arrests over a 3-hour period that it ran out of vehicles to transport the detainees to jail. So 3 days later, 1,200 people had been arrested across the city, which is a police department record, and this Operation Blue Crush was a success. So Larry Godwin, the city's police director, quickly rolled out a scheme, and by 2011, crime across the city had fallen by 24%. Crush is an acronym for criminal reduction using statistical history. And so a team of criminologists and data scientists at the University of Memphis first developed the technique using IBM predictive analytics software. So they looked at social housing maps, the U of M, and outside temperatures to use algorithms to find correlations in data for crime hotspots. So the conditions in the environment that are most linked to crime. So and the police just then flooded these areas with highly targeted patrols. So in other words, they found the areas and the conditions where crime is most common, and then they just really cracked down on those places. And so looking at that, you want to think of when do algorithms cross the threshold of good and bad. So in other words, if the Crush algorithm holds data, and if it's modified to be more precise, who decides how far it can go? So in other words, right now it just stands as a figure of how determining how likely a potential crime scene is, and it doesn't actually, it can't actually arrest someone itself. It's up to the police to interpret it that way. So in other words, how can it be kept from being too dangerous in putting in jailing people that are innocent? So since pure mathematics requires no prior sense of perception at the start of inquiry, but the application of mathematics to real-world situations requires techniques such as those that are used in the natural and human sciences. So what I'd like to look at here is finding the proper uses of algorithms. So, and my claim is that algorithms are used appropriately only when used to aid and speed human lives. So here's my claim. On the left, algorithms are used appropriately only when used to aid and speed human lives. Then my counterclaim is algorithms are not appropriate when used to aid and speed human lives, since algorithms can also produce negative effects potentially outweighing positive effects. So in other words, it's hard to tell whether an algorithm actually is doing enough good for it to be helpful. And so that's probably hard to see because of the projector, but what he's talking about here is how here, I'll try to project here. Yeah, so like he says, if you're looking for terrorists, you're looking for something very rare. But if you set your rules too tight, if you set your scope too tight, your criteria for finding criminals, then you'll miss a lot of terror suspects since it's too specific. But then if you look too broadly, you'll drag people that aren't even related into the problem. So then, of course, as long as you put the right people in the right place on the right day at the right time, then an algorithm works just fine, and it works like it's supposed to. So it's the question of whether you can make that happen every time in every case. So the purpose of an algorithm determines whether it's appropriate overall, I think, and then and the knowledge question of can and should we reduce everything in the world into an algorithm. So in the US, we know that we won't have enough general practitioner doctors, since not enough are being trained, and then because algorithms can replace a lot of their tasks. And also pharmacists are seeing some of their prescribing tasks already being replaced by algorithms. And so in other words, we might there's possibility of creating new and mundane jobs but algorithms will still need a human to do stuff in person. So they can do really simple tasks, but they are starting to replace some of the jobs of real people. So in this second real-life situation, which is Bayes' theorem, Bayes' theorem is a mathematical theorem used to compute the likelihood of beliefs according to probability. So that's done by narrowing down a hypothesis that you have based on information that you find out, and the areas of knowledge and ways of knowing are mathematics and ethics. And so Alan Turing and the Enigma code. During the Second World War, Alan Turing was a British cryptographer and mathematician, and he was brought in by the British government to help them crack the Nazi Enigma code. And so by doing that, he used Bayes' theorem. He looked at the number. The Nazi Enigma code was a code that the Nazis changed every day at midnight, and it was how they would relay messages to each other, and they were really easy to be intercepted since they were just like radio messages, but they had no idea what the Allies had no idea what they meant because they were in a different code, and they'd be decoded by the Nazi on the other end of the machine. So when he used Bayes' theorem to reduce the number of potential codes and find the Nazis' code, and so once they found out, they could find out their battle plans, and that kind of thing. So once they exposed the secret of discovering the Enigma code, it drastically changed the outcome of the war and completely turned it around. So and it made it almost impossible for the Nazis to win at that point. So, and Winston Churchill said that Turing made the single biggest contribution to the war effort. And the knowledge questions here of, did the Allies make the right decision in waiting to exploit the discovery of the code, and how justified were the lives lost before the secret was taken advantage of? But the main one I'd like to focus on is, what role does ethics play in the use of mathematics? So other words, yes?
So wait, they did not use I'm kind of confused on the code, they didn't use it?
They did. So what they did is, since they wanted to wait until the right time, because that's when you have such a big secret, you wanna make sure you can take full advantage of it. But it's the question of, if you expose it right away, then the Nazis will know and they'll be able to change that. But they were waiting for the right time where it would be impossible for them to do anything about it since they had cracked the code. If that makes sense.
Okay. Yeah. I was just.
Yeah. Yes. Yeah. Great question. I was going to get to that, but so next slide. So winning the war. The Allies made the right decision, is my claim, by waiting for a strategic time to expose the Axis. So they were justified in what they did. So even though they had a lot of their battles and that kind of thing, and unnecessary lives lost that could have been saved, they waited for the right time to expose the secret. So the Nazis would have been completely exposed. So. And the counterclaim is the Allies should have exposed the secret as soon as possible to save lives immediately. In other words, it wasn't worth the wait to make sure they had the biggest advantage from cracking the code. Is that they should have just said they had it immediately. And then my knowledge question down there. And so on my third one, you have. In 1968, there was an academic almost unknown in the UK. He walked into the University College of London and presented its staff with an equation so remarkable they offered him an honorary position and the keys to his own office. So the guy's name was George Price, and what he did was he made an equation that explained how altruism could thrive even among selfish people. So altruism is like a really human emotion, and but George Price thought it was exclusively to humans, since animals just focus on their own survival. And so what he did was what he believed is that people demonstrate altruism even though they're independent beings, because they want their family to survive and they want their genes to be passed down. So it's a natural instinct. And so here's the Price equation. And so what it looks at is the relationship between different generations of a population, as well as how the prevalence of certain traits would change over time. And so Orrin Harmon here he wrote a biography about George Price, and he summarized by saying that human beings are the only species that can beat out their own nature. In other words, they're the only ones that are in control of how they believe, the only species. So if altruism was simply an attempt to ensure the survival of one's genes, could it be considered altruism at all? And again, altruism is just going out of your own way and risking harm to yourself to help another being out. So what I want to look at here now is if it's logical to use mathematical theories and data to understand human behavior, and then can ethics and other AOKs be reduced to equations is my main point. And so altruism is dependent, and it's coincidental, and it's upon kin selection. So altruism depends on your family size and then that kind of thing. So.
Woo!